Before I start to teach algebraic fractions to young secondary school students, I often find that they have very limited understanding of basic addition of numerical fractions. My first comment is, please do not write fractions like this. Secondly, it is evident that many students are still being taught old rote methods that do not promote understanding at all. The mantra goes like this. Suppose we're adding these two fractions. We multiply the 3 and the 5 and get 15 as the new denominator. Then we say 3 into 15 goes 5, and then 5 times 2 comes to 10. And we do the same over here. We say 5 into 15 goes 3, and then 3 times 7 is 21, and then we get 31 over 15. Students who follow rote methods like this only know a routine, which the teacher says gives the correct answer. Students could be taught this similar routine just as easily under the misapprehension that understanding is being taught. This false mantra goes like this. It's a little bit complicated, but here we multiply the 2 and the 7 and get 14. And we make this the new denominator. Then we say 2 into 14 goes 7, and 7 times 3 is 21, and that goes there. Then we say 7 into 14 goes 2, and then 2 times 5 equals 10, and that goes there. And then the answer is 31 over 14. This is just the same idea. It's the same sort of routine as the one that is correct, but it has no merits at all. It's just a routine. There is no understanding involved. If students are taught that this is how to add fractions, they will think that they know how to add fractions, but they clearly have no understanding. There is a big difference between knowing something and understanding it. I often have to start from the beginning and teach fractions again, like this. Let's add 2 sevenths and 3 sevenths. I make a number line, split into sevenths. This length represents 2 sevenths. This length represents 3 sevenths, and so the answer is obviously 5 sevenths. And the diagram also shows that we can only add fractions with the same denominators. Consider these examples. 5 over 17 plus 6 over 17. There's no need to draw a number line with split into 17ths because now we know that it is just 11 over 17. Then we can immediately use algebra. The denominators are the same, so we just add these two, and it is a plus b over c. Now these are a little bit more complicated, but not much. The denominators are the same, so it stays the same, and we add the numerators, and we get 2x plus 8. This one slightly more complicated. The denominator x minus 6, and we add the numerators and get 8x minus 3. The difficulty comes when the denominator is not equal, of course. So this number line is now split into thirds, and that's a third. And this number line is split into quarters, and that's a quarter. Now, if I put these together on a number line like this, we have no idea where this is. We can only tell what the sum is when we divide the number line into twelfths. And of course, now we have a third is 4 twelfths, and a quarter is 3 twelfths, and so the answer is 7 twelfths. Now this is how we make the denominators equal. We realize they both go into 12, so we've got to make them into twelfths. So we multiply this by 1, and it doesn't change it because 4 over 4 is 1. So 1/3 is equal to this, which is 4 twelfths. Similarly, 1 over 4 is equal to 1 over 4 times 3 over 3, which is 3/12, and the answer, of course, is 7/12. Now we can apply this to algebraic fractions. We make the denominator BC, so we multiply by C over C, and we multiply this one by B over B, and of course we get C plus B over BC. Slightly more complicated, we just look at the denominators B and C, we multiply this fraction by C over C, which again is just 1. We multiply this fraction by B over B, which again is just 1. And so the denominator is BC, CB is the same as BC, and the numerators are AC plus EB. Getting more complicated, the denominator has to become x plus 2 times x minus 5. So we multiply by this fraction by 1 in the form of x minus 5 over x minus 5. This one we multiply by x plus 2 over x plus 2. Now I will multiply these top ones out and we get 4x minus 20, and here we get 3x plus 6, and I'll add those and we get 7x minus 14, and I think I will just leave those not multiplied out. And another one, a little bit harder. We multiply this one by x minus 2 over x minus 2. Multiply this one by x minus 5 over x minus 5. Then I think I'll have to multiply out the numerators and get x squared plus x minus 6. And here we get x squared minus x minus 20. Add the numerators and we get 2x squared. The x's go and minus 26. And I'll leave the denominator the same. The concept that knowing a thing is not the same as understanding it has been the focus of my teaching for many years. I have devoted a whole website to this concept, and I encourage educators to see my ideas. This is the website, and this terrible word here is actually just knowing is not understanding with no spaces. Easy to remember.